Hello, in this video I'll describe how to make the component of vector. Firstly, by the trigonometry you can see on the left hand side how to identify hypotenuse, opposite side and adjacent side. So you're gonna sit down on the 90-degree angle of this triangle and look at other side. So which side do you see? That is called hypotenuse, which is the longest side. Now there is three angles in this right angle triangle. So one angle is given. So this angle is given. Let's say I'll rename this triangle ABC. Now this angle A is given. So if you sit down this angle and then look at other side, whatever you see, this side is BC, which is called opposite side. Okay, so the other side which is remaining, which is AB, that is called adjacent side. Now if I change the angle, then opposite side and adjacent side also change. Let's say I'll draw this triangle. Okay, let's make it right angle triangle. Okay, this is not right angle, so let's make it a right angle triangle. So I'll draw over here. So let's take it. This is 90 degree. So let's take it. This triangle is P, Q, and R. Okay. Now look at from this 90 degree angle, which is side PR. You can see which is hypotenuse. Now let's say this angle is given, which is I'll write over here alpha. Okay, for differentiate with this number one triangle. So I'll write this is number one triangle. This is number two triangle. Okay, the bottom one is number two triangle. So now look at here, the angle theta is given at point R. Okay, at vertex R. So if you sit down over there and look at other side, you will see side PQ. Now in this case, the PQ is actually opposite side. Okay, opposite side. Now the remaining QR, which is adjacent side. Okay, now you know the relation of sine theta. So sine angle theta is equal to opposite divided by hypotenuse. Okay, so in this case, in first triangle is actually opposite is BC and divided by hypotenuse is AC. Now go back and look at triangle 2, where sine theta is, you have same formula, which is opposite divided by hypotenuse. Okay, so it means the opposite in our case is in second triangle is PQ and divided by hypotenuse is PR. Okay, PR. Now again go back and look at triangle A. Cosine theta is adjacent side divided by hypotenuse. So it means adjacent is in our case is actually for triangle first is AB. Look at this figure, and the hypotenuse is AC. Now in second triangle, cosine theta, you have same formula, adjacent side divided by hypotenuse. Okay, so this one is adjacent side. You can look at triangle 2, and adjacent side is QR divided by hypotenuse is PR. Okay, so if you change the angle from one corner to other corner, the adjacent and opposite side also change. Now and look at the other trigonometric ratio, which is tan theta, and that is equal to opposite side divided by adjacent side. So that is equal to opposite in first triangle is BC divided by adjacent side is AB. And in second triangle is actually given alpha, angle is given alpha, so I'll write instead of theta is alpha. Let's make it clear. So in second case is alpha. So if I define tan alpha in second triangle, which is also same formula, opposite divided by adjacent side, and that is equal to opposite is in our case is in second triangle is PQ divided by QR. Okay, now this is revision of this trigonometry. Now let's go back and look at how do you make components of a vector. Okay, components of a vector. So I'm making rectangular resolution, so I'll make two components. So let's say angle is given with x-axis. Okay, the first one is this is x-axis and this is y-axis, and let's say vector component, I'll make one component. Let's say this is 35. Okay, and angle is given with x-axis, let's say 20 degree. Okay, 20 degree. Now if 20 degree is given, you can make a right angle triangle by drawing this line from over here. So I'll write this OA, and this one is, let's say, OC. Okay, OC is vector which is 35 units. OA is x component, so I'll write AX, x component, and AC is y component. I'll write that's a AY. Okay, and this is vector A, let's say 35. Now if you look at this right angle triangle OAC, you can define this AC. AC is opposite of this given angle 20 degrees, so that is opposite side, and OA is actually adjacent side, and OC is hypotenuse. Okay, so then sine theta is equal to, your formula is opposite divided by adjacent. Yes, no, opposite divided by hypotenuse. Sorry, I'll delete this one again. Let's say opposite divided by hypotenuse. So in our case, sine theta is actually in my case is given sine theta is angle is given sine 20 degree is equal to opposite, which is AY, I don't know, and divided by hypotenuse, which is A, which is given 35. So if I cross multiply, I will get AY is equal to 35 sine 20 degree. Okay, similarly to calculate x component, if I make cosine of theta, which is, you have formula is cosine of theta is adjacent side divided by hypotenuse. Okay, so it means cosine in our case is given 20 degree is equal to adjacent side is, you have OA, which is AX, divided by hypotenuse, which is OC, that is given A, which is magnitude of 35. So if I calculate AX, I will get 35 cosine 20. Yes, so which is a case of if angle is given with x-axis. Now let's change this angle to the y-axis. Just make sure you have same values. Okay, so I do have same values. So this is y-axis and this one is x-axis, same thing. So let's say this magnitude is also same. Okay, so let's make it A is equal to 35, same thing, but instead of this one, I'm just making this angle is 20 degree with y-axis. Okay, I change it, so angle is 20 degree with y-axis, means x-axis angle also becomes 90 minus 20 is 70, so that is different. Okay, so let's make it right angle triangle over here, because angle is given with this y-axis. Okay, so this is OA is vector. Now I'll write this point is B point. Okay, so we do have right angle triangle in this case is OAB, OAB. OAB. So this angle is given. So opposite side of this angle, which is AB, that side is actually in our case is opposite side. So AB is opposite side in our case, and this is AB is in along x-axis, so this component is AX. So OB is along y-axis, so this component is AY. Now in this triangle OAB, let's say define sine theta. Okay, sine theta, which is you have same formula, opposite divided by hypotenuse. Okay, now sine theta, you have angle is given 20 degrees, so theta is 20 degrees. So opposite in triangle OAB, the opposite side is actually AB, which is, if you look at it from the angle which is given 20 degrees given, if you look at it from there, you do see AB. So opposite is AB, which is AX component. Yes, and divided by hypotenuse, which is OA, which is given 35. So you calculate AX is equal to 35 sine 20 degree. Okay, now look at the previous example. Look at here, AX in this case is 35 cosine 20, but in our case, in second case, is AX is 35 sine 20. So X component change if you change the angle with x-axis or y-axis. Similarly, let's calculate cosine of theta in this second example. So I'll write this one is first example, let's say, and this one is the second example. Okay, and cosine theta is, you have same formula over here. Look at this formula, which is adjacent side divided by hypotenuse. Okay, so cosine in our case is 20 degree is given, theta is 20. So look at here this triangle in the second example. So AB is opposite, so remaining OA is hypotenuse, so OB is actually adjacent side, so that is OB is AY divided by hypotenuse is OA, which is given 35 magnitude. So if I calculate AY from here, I'll get 35 cosine 20 degree. Good. So in first example is y component is 35 sine 20, but in this second example AY is 35 cosine 20. So look at here, there is cosine component, here is sine component. Yes, so its components also change. So in nutshell, if you look at this example, if x angle is given, angle with x is given, then x component over here is cosine component. Okay, cosine component. But if angle is given y-axis, then you can say from here is it's y component is cosine. Look at here, y component here, and this component is cosine. So in summary, I can tell which angle, the angle which axis is given, that component is cosine component. If x angle with x-axis is given, then x component is cosine component. If angle with y component is given, then y component is cosine component. The other component automatically becomes sine component. So that way you can identify sine and cosine component from a vector, or you can make a rectangular resolution, making rectangular components of a vector. And there is other method also calculate these components by considering what is the angle with x-axis, and you can see my other videos to look at how you can do that. But this is one method how to make a rectangular resolution of a vector. Or you can also say two components perpendicular to each other from a vector.